Hi guys, Mathmaster here, and today we're gonna be doing how to convert to and from base 10. So first of all, what is base 10? Well, nobody says base 10, but it's actually the common form of how we express numbers. So in base 10, there are 10 digits: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? You learned this in kindergarten. Very basic stuff. So this is base 10. This is in base 10. There are 10 digits. But why are there 10 digits? Why can't there be a different number of digits? Well, there can be a different number of digits. It's just that base 10 is commonly used. But if you want to use a different base, for example, if you want to use base 5, well, it's pretty similar to base 10. So in base 5, the digits are 0, 1, 2, 3, and 4. There's 5 digits. So you can still make all of the numbers from 0 to infinity using these 5 numbers. So first, let's look at the notation. So here, if you want to say like 9, so we write it as 9 subscript 10. So this represents the 9 in base 10. And similarly here, if you want to write 3 in base 5, then it's 3 subscript 5. So then the person who's reading this knows that we're talking about it in base 5. Okay. So basically here, 0 in base 10 is the same thing as 0 base 5. And the same thing for 0, 1, 2, 3, and 4. So 4 base 10 is still 4 base 5 because base 5 still has 0 to 4. But then when we get to 5 base 10, well, it can't be 5 base 5 because the only digits in base 5 are 0 to 4. So now we have to do something that's pretty similar to base 10. So in base 10, if we're at 9 and we want to add 1, well then we have a problem because there's no digit after 9. So what we do is we loop back around and then we add a 1 at the beginning. So 9 plus 1 is 10. So we can use a similar thing here. So since we're 4, we have to loop around back to 0 and then add a 1. So 5 base 10 is 1, 0 base 5. And I'm saying 1, 0 instead of 10 because, well, that's just how you commonly say it when you're not dealing with base 10. Okay, so similarly, 6 base 10, well, this you're just adding 1 to 5, so it's 11. And then the same thing for 7, 8, and 9. But then when we get to 10 base 10, so 9 base 10 is 14 base 5. So now when we get to 10 base 10, we're at another problem because, well, you can't go to 5. So you do the same thing, you rotate back to 0 and then add 1 to the 10th digit. So 10 in base 10 is 20 in base 5. Okay, so it's a similar thing for the rest of the time. So then once you get to 24 base 10, well, you can check. This is 4, 4 base 5. So now in 25 base 10, well, we can do the same thing. We can loop this back to 0 and add 1 here. But now we can't add 1 because this will be 5 and 5 doesn't work in base 5. So then we do the thing that we do in base 10. This 5 becomes a 0, similar to the units digit. And you put a 1 in the hundreds place. So this becomes 100 base 5. Okay, so now how do you convert from a base 5 number to a base 10 number? So let's just take an example. Let's say you have 2, 3, 1 base 5 and you want to convert it into base 10. Well, let me just erase this. Okay, so in base 5, how it works is that the units digit has value 1, similar to in base 10, it also has value 1, except that now the tens digit, it has value 5 because we're in base 5. And in base 10, it would have value 10 because we're in base 10. And similarly, the hundreds digit has value 5 squared. So say that this number 231, say that it's in base 10. So then we can write it as 2 times 10 squared plus 3 times 10 plus 1. Well, it's the same thing for this as well, except a different subscript. So it's 2 times 5 squared plus 3 times 5 plus 1 times 1, I guess. So this is the base 10 representation. So then if you simplified, so 5 squared times 2 is 50, 3 times 5 is 15, 1 times 1 is 1. So it's 66 base 10. Okay, so we know how to convert from a random base to base 10. What if you want to go the other way around? So say now we have, I'm just gonna erase this because I need some more space. So now what if we have our base 10 number, let's say it's 66, and we want to convert it to base 5. Well, it kind of works converting it from base 5 to base 10, except that it's backwards. So first of all, we have to find the highest power of 5, which is less than this number. In this case, it has to be less than 66. Okay, so that's pretty easy, it's 25. So now we have to multiply this number by a constant so that it's still less than our number, 66. So 3 times 25 is 75, that's too big. So 2 times 25, that's 50, and that is still smaller. So you have 2 times 25. So now let's do 66 minus 2 times 25, which is 50. That equals to 16. So now we repeat the same process on 16. So what's the highest power of 5, which is less than 16? That's just 5. And then what number do you have to multiply it to so that it's still less than? So it would be 3 times 5 because 15 is just less than 16. So once again, we have to do 16 minus 3 times 5, which is 15. So that equals to 1. So it's 1 times 1. So now we can convert each of these numbers to base 5. So 2 base 10 to 2 base 5, it's just 2 base 5 times 100 base 5 plus 3 times 10 base 5 plus 1 base 5. Okay, well, you can see here that now it's basically the same thing as using base 10. You just smush together the constants, so you get 2, 3, 1 base 5. And indeed, that is our answer. Okay, so now we know how to convert to and from base 10. Let's hop into an example. So 441 in base b is n squared in base 10, and 351 in base b is n minus 2 whole squared in base 10, and what is b? Okay, so first let's convert 441 base b into a number base 10. So the 4 here has value b squared, this 4 has value b, and this one has value 1. So in base 10, this number is 4b squared plus 4b plus 1. That's what it is in base 10, and we're also given that it's n squared in base 10. So these two expressions have to be equal to each other. Now notice that the expression on the left is 2b plus 1 whole squared, that equals to n squared. That means that we have that 2b plus 1 has to equal to n. Okay, so this should be pretty helpful. Now let's do the other information that we are given. So here this has value b squared, this has value b, this has value 1. So 3b squared plus 5b plus 1 equals to, here we're given that it's n minus 2 whole squared. Okay, so now we can substitute n and find the answer. So 3b squared plus 5b plus 1 equals to 2b plus 1 minus 2. That's 2b minus 1 whole squared. Okay, well now this is a simple algebraic equation. Everything is in base 10, so we don't have to worry about that. So let's just expand it. So it's this, and then subtracting a lot of stuff, we get that it's b squared minus 9b equals to 0. Well then, the only two values of b which work, like first we can factor this. So either b equals to 0 or b minus 9 equals to 0. Either b equals to 0 or b equals to 9. Well, if you think about it, a number in base 0, well, which digits would it use? It wouldn't really use any digits, so it kind of breaks like the algorithm. So 0 does not work, so our answer is 9. And we can see that n equals to 2 times 9 plus 1, which is 19. So you can check for these two equations and you'll see that it works. Okay, this video is getting kind of long, but quickly before I end it, let's go over the MATHCOUNTS problem we did yesterday. So we wanted to write 2010 in balls, like by putting balls in urns. So if you didn't watch yesterday's MATHCOUNTS problem, you should probably watch it now. I'll probably put a link to the right so you can go check it out. So 2010, well, each box can only have 0 to 4 balls. So 0 to 4 are the only digits that can be inside each box. So it kind of reminds us of base 5. And indeed, if you convert 2010 base 10 into base 5, well, let's do that real quickly. So it's 625 times 3 plus 125 times 1 plus 5 times 2. So this equals to 3, 1, 0 because there is no multiples of 25, 2, 0. And this is the number we got yesterday as well. So then when you add up the numbers, you get 3 plus 1 plus 2, which is 6. This is also the answer we got last time. So I solved this problem in like about 1.5 minutes. So this is a really fast way of doing it. But if you didn't notice this, then you can do it the way I did it yesterday. Okay, so this is pretty cool. Thank you for watching this video. I hope you enjoyed. Please like and comment down below, and I'll catch you in the next one.